Alrighty. Can everybody hear me? Awesome, awesome. Alrighty. Welcome in, guys. Thanks for joining us on such short notice, honestly. This has been on in the planning. It's not that we forgot about it. It's just been a very hectic weekend and week. So excuse us for doing this a little late. Um, okay. So obviously, I would like to begin by saying that this is not a new workshop. This is the second part of data cleaning. We did the first workshop of last year was also data cleaning, which you can find on our YouTube. However, I decided to do this one again because genuinely your AI model is as good as your data. So knowing these as a refresher, maybe you guys would rather have a live interaction instead of sort of a video, it would be nice in my opinion. So without further ado, if anybody doesn't have any questions, we can go ahead and get started. Okay, so first things first, I want to explain a couple of things. So it is important to realize that not every data set that you are provided is going to be clean, and this is not necessarily for the datathon itself, but in the workforce, when you actually get files, a lot of times there are a lot of invalid characters, a lot of things that might break, genuinely break um, your database or the application that you're using because it is not clean, or better yet, if you have for example, AI model that you're trying to build with that data, if your data is not cleaned properly, then you will, and that's without a brainer, that's without any doubt, will have issues or will run into issues. So I'm going to bring up a tiny little data set that I put together to go over the example and to walk you guys over and let me put it over here. Okay, so this is an example data set that I put together. It is, I forgot how many rows it was. I think it's like 3,000 or 5,000 something. Yeah. This is like 5,036 pieces of information. And some of them are clean, some of them are not. Some of them are good to go. Some of them have issues as per rows. So understanding how each of the fields need to be mapped, I think is relatively important. For example, as you can see over here, for is member column, we have different values. We have trues, we have falses, we have yes, we have no's, we have y's, we have n's. Uh, and that is not zeros and ones, and that's not a very clean way to handle this. So when you are trying to create an AI model, whether it is supervised, unsupervised, if you're doing NLP, feeding it into a large language model, this causes confusion. This causes issues, and at best case scenario, it will cause um, what we call, what was it called? I forgot what it was called. Um, Practically an inaccurate model. But we're here to clean this data set that we have over here, and I guess let's get started. So there are a few libraries that we usually use. that are standard. It's industry standard if you're using Python. It is easier to work with. There's lots of documentation, lots of code examples. And whether you guys want to follow with me on this or would rather test out the code afterwards, it's totally up to you. I'm going to start with importing um, the packages, pandas, NumPy, and import re. And then for pandas, we're going to use a set function, max columns to none, and pd dot set option display dot width to be 200. Now we will see this visually in a little bit, but if we say df raw equals pd dot read CSV, which is usually the format of the file we get, messy orders.csv, NA values to equal, let's say, okay, these are for values that are non-existent or non-applicable. What are some examples that you guys can think of a field that is non-applicable? For example, as you saw in the sheet over here, we had some yeses, some falses, some trues, some zeros and ones, some ends, some Ys, stuff like that. But if we were just talking about a field that was like empty or NA like this, what are some other examples that you guys can think about? Does anybody have an idea? I'll give a hint. For example, NA lowercase, question mark. Uh, no, undefined exactly. No. Oh my God. Uh, uppercase, for example, I'm gonna say none or also not available. Something like that. And after this, I would like to also keep default NA to true, as it will help us to keep one of these. Um, and then after we do this, after we read our CSV or pretty much put it in a bucket, put it in a container, put it in a variable, we do df equals df, our data frame, uh, raw dot copy. So we're going to copy what we have um, on the top because it is better to work on a copy rather than the actual data. Because if you lose something, you lose the copy and not the actual data. Now, you may be asking, oh, Sarush, would this edit the file directly? Not necessarily, not always, but when we do have the resources, as we do in Google Colab, for example, um, we can use a copy to make sure everything is streamlined and everything's okay. And we set we call the head pretty much so that it will set it to the very, very top. Okay, any questions so far? All right, we'll continue. So, rule of thumb is inspect first, clean second. And there are a few points on this that I think is worthy of mentioning. For example, dot shape is determines how big is it? We have dot d types. Actually, you know what? I'm not going to waste time typing all of this. I'm sorry. I apologize. It's okay. I think we can skip past this, but I want it to be here. So, shape is how big is it? D types or info, what does Panda think each column is? Describe, include all, does a quick numeric in categorical summary, and is NA dot sum, where is the missing value? So it will pinpoint exactly where we are missing values, for example. Now, why does this matter? Why do we go further down a loop to get this going? Why do we even bother? Why not just like screw it, dude? We can just read the file ourselves. Yes, but what if you miss something? What if your Excel sheet or the CSV file that you've been provided has millions of leads in it, millions of rows in it? How are you going to analyze that one by one? Does it even make sense? No, we are machine learning people. We have the ability to actually make this work. So rather than doing it that way, we can do it ourselves. With the code, make sure to streamline the process properly. So let's say shape, and I will say df.shape, and then I will also say df.info over here. Okay, and because of the visuals, I think it would be better if I do this way. Let's say df.describe, describe, and I'll say include equals all. So it includes all of the columns. Um, and then we'll do a dot T here, which I will explain later. Keep it. I will explain as we get to it. So then afterwards we say just to see what values might be missing. For example, missing equals df dot is na dot sum, as we mentioned in the top, dot sort values ascending to be false. So it would be descending pretty much. And then missing, missing is bigger than zero. Okay, now you may be asking, Surush, how do you know all these syntax? Truth is, some of them I do out of practice, some of them I don't. I look them up every time I need to look at. Um, Part of the competition this weekend is for you to understand what is the limit of human and what you can streamline with the use of AI. Because um, we're at a position in the industry where every employer is expecting programmers to be a much, much more productive person using AI. So if you don't use AI, you're behind practically in their eyes. So as the industry is shifting, we have to adapt as well, or we will be replaced. Do we want to be replaced, guys? Nah, nah. We're good, right? We want to keep our jobs. Or get a new one. Get a new one. Possibly question mark. Okay, so I'm gonna see if I can get this to connect first. Let's see if the first part, yes, okay, we're good. The error is because we don't have the file in there yet. Do not worry, we'll get to that. I'm not worried at all. I just wanted to see if these the imports would pass properly. So we're okay. But I guess since we are here, let's upload the file and see if we can get this to run. Run all. Okay. All right. All right. So, we got our data over here. As you can see, it has just four examples up here. Tom Johnson. I don't think this is order. Actually, it is. Okay. So we have Tom Johnson, Alice King, well, Jay Walsh, and Frank Chen. And Leo Johnson. So we have these as it was inside of our Excel sheet or the CSV file. This is the exact copy, this exact import. We're to get the screenshot to follow along. Oh yeah, absolutely. Yeah, yeah, yeah. Thank you. Yes. Let me send that. Is chat okay? Can I send it in the chat, or do you guys want the link to the spreadsheet? I can do that too. Uh, Allow me. Here you guys go. I put it in the chat. Let me know if you have any problems accessing it. Yeah, yeah, no problem. And then after we describe all of the columns, after we use df.describe or data frame.describe, what we get is rather interesting. Rather interesting. Hmm. What do we have here? So we have a set of stats as columns now, and we have each of the columns we have in the file down here as rows pretty much because it is explaining everything. So we have 5,035 order IDs. Is it unique? Not applicable, not available, whatever. What is the top? We don't know. Frequency, we don't know. What's the mean? What's the STD? The mean, the minimum, the 25 percentile, 50 percentile, 75 percentile, and max, right? So that's for example one over here. And then customer ID, we have a count of 4,925. Now, knowing that we have, where is it, 5,036 people in this list or orders in this list, I think we might have some problems here because that number is significantly less, right? Now, just scrolling through it, can you guys realize what's missing? Can you realize all of the things are missing that are missing? Does it make sense for us to do that? No. So we use pandas and NumPy, well, pandas for now to clean the data little by little. And then country, same thing. There's 4,921. Uniques are 45. Top is France. Frequency is 174. It doesn't have a mean, a minimum, 25%, 50% max, whatever, whatever. Um, well, we can see how this can give us some pretty useful information. Now, when we go to the missing section, right, where we are using all of, we're trying to get all of the missing values, you can see 213 discounts are missing, 186 ages are missing, 152 sign up date, 114 countries, customer name 110, is member 108, email, blah, 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 blah. Does that make sense? So now if we wanted to look for each of these individually, Doc, come on. This is a 5,000 row file. Imagine if it was a million. And a million isn't something crazy. Believe me when I tell you, there are when you do work with big data, yeah, yeah. It does happen more frequently that you can imagine. So let's see. Okay, so any questions so far before I continue? No, no. Okay, sweet. All right. So I'm gonna add this over here, and this is really important to know. We read the document. Now it's time for cleaning itself. So, but part of that is handling the missing data. Now that we have the missing data, we have to take care of them, obviously. But what are the methods to do this? So we have dropping the row as a strategy, which the row is mostly empty or missing a column that is critical. Drop the column, a column that is mostly empty and not load bearing. It doesn't have much importance to our AI model, for example. Fill with a constant. For example, if the discount is empty, you just put zero in it. Fill with a statistic, uh, mean or median for numerics, mode for categorials. Forward fill time series with known carry forward semantics. Leave as NaN. Downstream tool handles, for example, XGBoost. Uh, let's try some of these, shall we? Okay. Okay, so I'm gonna say threshold equals length of our data frame dot columns floor divided by 2. Before equals length of data frame. df equals df dot drop na. Oh my God, I'm typing this in. Is this code? No, this is text. Oh my God. Well, there we go. Thresh equals threshold, and then we print our f dropped before minus length of df, mostly empty row. Okay. Let's see. I'm gonna do this one after. I'll do another code block just in case. This would be, um, well, before I move on, can I ask a question? What does this do? Why are we setting the threshold to the maximum or the length of our columns? Floor divided by 2. Why not just divide? To not have decimals, correct. To not have decimals for one, and we are doing 50%. Depending on the use case, you might need to do 70%. You might need to do 30%. You might just be okay with like 20% of it. But we're doing 50 because it's in the middle. We don't care about this data set all that much. But yes, correct, Andre. Thank you very much. Um, this part is working on the rows that are mostly 50% empty or 50% or more empty. Now, what if we work with a default, for example, where the discount example that I made, if I say data frame discount right here equals df discount dot fill DNA with a zero. Now that was pretty easy, but what if the field is a string? It's not numerical. If it's the customer name, for example, df customer name equals df customer name fill NA unknown. Yes, thank you. Thank you, autocomplete. Let's say email again. Same thing. I'm gonna do unknown add unknown nian dot unk. Why? Because it is funny. Because I'm 57 years old and I find that funny. Let's say, no offense to 57-year-olds, by the way. DF country fill unknown, yada yada yada. We have I don't care about these for now, but what I do care about is the product. Does this make sense? Everybody, any questions? No, no. Let's say a numeric column that we have and it doesn't have any values in it, and we want to put a decimal in it. How do we do that? For example, the median, for example. So here I'll say dfh equals df h dot fill na. Here gets interesting. Dfh dot mean is what we will put in there, or I think it is median. If I yes, I think that's the correct. And then we will print median age is df age dot median. Okay, so that we have all of that, and then at the very bottom of this, I'm gonna add another code block with brother. Get out of my face, Gemini. I'm gonna do df is na sum just to get a idea of how it will work out. Okay, so let's see. We ran this. We dropped 5 mostly empty rows. We had 5 rows in there that had less than 50% of the data filled. So we dropped. We ran this. We ran this. The median age was 47. And now after doing this cleaning, we have 0. All of these are 0 NAs. in comparison to this. Isn't that cool? The only thing left is sign update, which I really didn't care about, or is member. Now we will get to is member. We're going to clean practically everything here, but it is important to do part by part. Any questions about this part of the cleaning process? Alrighty, then I will move on. Let's talk about duplicates. If we have exact duplicates, for example, we have what would be a good example of this? Two rows that are exactly the same. That's a very common thing that happens. We had to deal with a lead at work today, actually, that people were using exactly the same situation. It was a duplicate. That happens quite often. User error, machine error, every way possible this does happen. So let's have a little section for duplicates. Code. Okay. Now, we have exact duplicates. We have duplicates by business key, for example, or or different ways to handle, I guess, um, others. So we have exact duplicates and other duplicates that we have two examples for, and I'll go over. Here I wrote it as logical duplicates. For example, same business entity, but different casting white space types, which also happens a lot when you work with data like this, and it causes a lot of issues. So if I say exact dupes equals data frame, data frame dot duplicated keep equals false, and then print. I'm just gonna say length of exact dupes like this, and then actually it won't look nice. So let's actually make it look decent. Rows are part of an exact duplicate set. Wait a second, what's wrong here? Oop. And then exact dupes dot sort values, and we'll do it by order ID. And I know that there's not a lot, but if you want to display just 10 of them, you will do dot head 10. Um, this is to handle exact duplicate rows. So if I run this, we had 20 exact rows that are part of an exact duplicate set. So we removed them. Um, or I guess not yet. Or did we remove them already? Can someone tell me if we have to remove them already or not yet? The answer is You are correct, Andre. However, exact dupes is a container that holds all of the duplicateds that we are not keeping. I'll explain a little bit more in a second. So technically, our data frame itself doesn't have these removed yet, but exact dupes is our data frame with the keep removed, or with the dupes removed, if that makes sense. Let's talk about another example for logical. For example, here we have order numbers. Does that make sense, Andre, by the way? Okay, sounds good. Thank you very much for your confirmation. Okay, so let's do ID dupes equals df duplicated subset order ID. That is correct. How does it know? That's exactly what I wanted to write. Yep. So run this now. Okay, so by order ID, 59 rows are part of a logical duplicate set. Now, what happens over here is that we have 59 rows that have the same order IDs. That is a problem. And you can see there a lot of them are very similar. For example, this is Olivia Rossi and this is Olivia Rossi. You know, it's the same thing, just different tonation. Some people might be a little more angry. Yeah, so it's type errors. It's human error for the most part, or it is caused by something that is insignificant but doesn't make sense for us to keep it in the data set. It can cause false positives or false negatives. We don't want to keep them. And then now we drop everything. So we say before equals df or length of df. Df equals drop duplicates. Df equals df drop duplicates. Uh, I'm going to make a little bit of a difference to this. So now here's the thing, right? If I do this right now as it is, it will drop 10 rows, right? I'll drop all of them. However, if I do uh, subset equals order ID and I set the keep to, for example, first, it will keep the first one, but it will drop the second always. So now it dropped 20 duplicate rows. So specifically knowing what you are asking it to drop is another important factor. You are in control of your data. Always, always, and always. You are the data scientist. You are the person who determines what is worth keeping and what is not worth keeping. So rather than just doing whatever, just deleting the duplicates, sure, that might help. That might be useful. But when you do it this way, you are going to get more accurate results. And part of the competition, wink, wink, spoiler alert, part of the competition grading on Friday is this, is what accuracy you achieve with your model. What is going on? We have a baseline for each of them. We have a baseline for each of the data sets, and we are giving you the chance to either get as close to that threshold as possible or surpass it. I'm not saying more than that. Uh, but what choices are you making to get to that point? What are you doing to go above and beyond? Are you cleaning your data properly, or you're just dropping duplicates? Plain old and simple. Um, if you guys don't have any questions, I will move forward. I am recording, right? Yes. Okay. Ooh, that scared me. Okay, okay. Now, let's talk about what's the difference between the two duplicates? You mean exact duplicates and logical duplicates? Okay. So, logical duplicate is where it is tied to a entity, a column, for example. In the second part of this, we did order ID, for example, as a tie. The duplicates were tied to order ID. We had duplicate order IDs. But when we talk about duplicates in general, we are talking about rows that are exactly the same thing. Does that make sense? So see here, for example, we did df.duplicated keep false, right? These are all of the duplicates. So it gave us 20 rows that are exactly the same thing. Exactly the same thing. But then here, when we did a subset by order ID, stories changed. We now have how many? 59 rows that are duplicated just by the order ID. See, the fields themselves might not be exactly the same. They might be exactly the same with different tonations, different typings, errors here and there, less fields, some might be unapplicable, some might be empty, but they're not exact copies. So they will not be part of this. Make sense? And the logical duplicate requires the subset stuff? Yes. Yes. So you would have to do it based on each of the columns, for example. Now, the question is, do we want to drop duplicates by age? Like if we find rows that have the same age, does that make sense? No, that's kind of stupid, right? But do we want to drop the rows that are duplicated in, for example, the product? Do we want to do that? Also no. Country, also no. Customer name, mm, mm, maybe a little bit iffy there. I rather not risk it because there's a lot of people with the same name. As a matter of fact, I'm gonna Google this. How how many people with the same name uh oh actually okay, I'm gonna type in one of these names, for example, Tom Johnson. Tom Johnson. Estimated people with your full name 371. That is not horrible, you know? So on a big database, on a big data set, this might happen. And you don't want to mess with it. So, but for something like customer ID or order ID, when you have a field that repeats itself, it is significantly more important to uh, pay attention to these stuff. two order IDs that are the same is usually a red flag. If it is system generated, it usually never generates the same thing. If it is not system generated, what happened? You know? Does that answer your question?
Sorry, I'm gonna just go ahead and unmute because I'm typing a lot. But
Go ahead. Hit me.
for this data set, how is it that like they have duplicate order IDs? Is that just like from the system, like when you were making the data set, you just like
Uh,
made, or like what would be
how is it the how is that I used Claude to put some fake data in it? Yes.
gotcha. But like
I
in
I
an actual
dirtied it myself.
in like an actual data set, like what would be like a significant like column or like kind of variable that you'd look at that would be like, okay, this
Order
would be some
ID, order
order ID.
ID, customer ID, stuff that are supposed to be unique.
Okay,
100% supposed to be unique. Email, for example, yes. But
gotcha.
again, Andre, that is a very, very, very important thing. If you're looking at emails, a person might have placed multiple orders, right? So the email is going to be the same thing for the same customer. However, this has to be unique. Um, yeah, but in different use cases, obviously, this is going to be different, as you said. It's just a little bit of as Professor Ebert says, mental protein of the day. Just to go over it and see what exactly you need to take as those unique identifiers and clean them. Does that answer the questions? Yep. Okay, sounds good. Thank you. Thank you. White space, casing. Very important. Very important. Very, 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 very important. Yes, with all caps is not the same as yes, lowercase. Why? Because if we go by ASCII table, they have different values. When they're stored, they're different. Blah, blah, blah. We all know this. So what we will need to do is make sure if there is a possibility of different casing, we are um naturalizing all of them. So there's one base, either all capitalized or all lowercase for things for columns or yeah, for columns that don't have case sensitive information, which usually is the case. Uh, okay, so we're going to strip the white space first, for example, if we have any extra white space anywhere. STR columns, I'll say calls, equals df dot select d types include object dot columns. All right. Joke's on you. I'm not going to use that. We're going to say Jesus Christ, man. Let me work. For column in str columns, df column as type. Is that correct? No. Uh, dot as type strip. And then here we do df dot d pause df equals df dot oh my god dot replace nan with numpy nan. I'll explain this. I'll explain this. Actually, I'm gonna do that because I know the dataset doesn't have it. This thing is both helpful and annoying at the same time. Okay, now I'm gonna do df customer name, uh, email for the time being. Oh shoot, this was wrong. It's a 2D array actually. Dot head 10. Okay. Can anybody tell me what we're doing here? You guys can unmute as well if that's more comfortable. If you guys have an idea, want to talk about it, unmute. That's all good. What we are doing is removing um, white space. We're stripping the white spaces from every object string inside of the column, customer name, or every column practically. However, what we are also doing here is we are replacing all of the NaNs, nan, and nuns with numpy.nan, which is a unifying everything to be strings. Because the type of numpy.nan is string, I believe, if it shows over here. Or float, my bad. Jesus Christ. But if I create another code sample over here and work on the casing, for example, here, and I do a df customer name, that is exactly correct. That's exactly what I wanted to. Customer name, string title, email df email str lower, uh, product is title. I'm gonna add product in here too. Can anybody tell me what str.title does? It's a pretty interesting method, actually. It is used to convert each string in a series or index to title case. Um, so, for example, we can see here in customer name, we have Tom Johnson. T and J will be capitalized, the title. And then product M or charger, webcam, USB hub, all of those. But if I do this as lower, for example, we can see that all of these are lowercase now. Does that make sense? So that's another important factor. to consider. Because again, these can create false negatives or false positives depending on what you are doing. Let's see. I'm gonna speed up because it is 8. If you guys are fine, I'm going to copy paste code into here little by little and talk over them one by one. And at the end of the meeting, we will uh, share all of this so you guys get a chance to do it yourselves if you didn't get to follow through, or for people who are watching online. Let's see. There's another problem. Different data types in a single column. There are instances, for example, where price USD, if I run this, for example, we can see we have 25.99, that's a float. 899.0, that's a float. $sign 89.50, that's a string. 89.5, that's a string. That's a string. That's a string. That's a string. This is a float again. This is a float. That's not good. That's not good. We don't want that. We don't want that much uh flexibility or openness in this because it might break. Depending on what we're doing, this might cause breakage in our data cleaning or data processing actually. So I'm gonna paste this one. Now, it's if we say if we strip the $signs, the commas, and then convert them, set the errors to course, turn anything unparsable into a non or a nan, then we are good to go. For example, here what we're doing is we're converting it to a type string. We're converting all of them to a type string. So everything in the column price USD is now a string. Then in that string, we replace all of the $signs uh, with nothing, and then we strip it. After we do that, we change to numeric. And if we have any errors over here, we'll set them to nan. Quantity should also be numeric, so we do it for quantity and age. After we run this, we can see all of them are float 64s. Now we have unified. Make sense? Let's see. Add a text over here. Next part that I'm going to talk about is standardization. This is also very important. Very, very, very important. Country contains USA, U.S.S. United States, US. All the same place. Same for status, completed or completed or completed or done in different casing. Build an explicit mapping. Don't try to be clever with this. With fuzzy matching for known small vocabularies. Analyze all of your data. That's on you. So it is best to do this yourself. I'm going to copy this. I have a map that I created specifically for this. USA, United States, USA, US, US, United States of America, United States, and then UK, UK, United Kingdom, United Kingdom, United Kingdom, England, Britain, uh, Britain, Canada, CA, CAN, Mexico, Mexico, MX, MEX, China, CN, PRC. You get the idea. You get the idea. All of this will then unify everything for us. We write a function over here to normalize the country. We feed it the column. And if PD dot is an NA, we return itself. If the key is when we set the key to the stripped down version of this and return the country map dot get this guy as a key. What the value would be then would be fed in there. So now we have Germany, France, Brazil, United Arab Emirates, India, Canada, Italy, Spain, Ireland, Japan, China, Mexico, Singapore, United Kingdom, United States, and 108 unknowns. Um, that is before normalizing. My bad. This is after normalizing. I'm sorry. I'm sorry. This is after normalizing. Though if I add another code block over here and have the status map here as well. Jesus Christ, I keep clicking on this. Uh, Same idea, same thing. Now we have everything cleaned. Completed, completed, done, shipped, shipped, pending, pending, canceled, canceled, return, return. So same idea. We have a key and a value. We map the key to the value, return the value, make sure everything's the same thing. Any questions on these? Everybody okay? All right. The next one is something that usually gets messed up really quickly and a lot of people don't pay attention to it. Dates and times, multiple formats. It's truly a nightmare. It's truly horrible when you get a data set which has complete different types of date time formatting inside of it. For example, with dashes, with month, with MMDDYYYY, or DDMMYYYY, or March 21st, 2024, for example, all of these. They are truly, truly horrible. And it is rather important to take care of that as well. It is very, 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 very important. I'm gonna have a little example over here for um, we try to permissively parse them first. So order date and sign up date, what we do is we use PD to date time. Order date, we set the error to course. Format to mixed and day first is false. And then the same thing with sign up date parsed. And we want to see which one of these rows then later fail. Uh, and I guess I did not make the data set dirty enough. It was pretty clean. So we didn't have any failed ones, but that's, I guess, pretty good. Um, Keep in mind though, this is a sample that I'm giving. Even the data set, even if the data set doesn't have it, it is important for you guys to go through this. Just to double check, just to be sure. If you see multiple different types of date formatting, go ahead. And here I'm just dropping the columns and we just have the parsed columns. We replace the originals with the parsed columns pretty much. So initially it was here we had, what is it? Order date and sign up date, and you can see they're completely different formats. But then we create two new ones. We parse them with these and then replace the old ones with the new ones that we just made. Any questions? Alrighty, moving forward. Next step. My best buddy, Booleans, yes and no's, trues and falses, ones and zeros, y's and n's, all important. Uh, but we have to have a unified system. Do you guys have an idea of how we do this based on what we have done already? Can you guys tell me what would be a good way to handle this? Ones and zeros would be good. Usually the way to go is ones and zeros. However, if we are keeping the type, if we are keeping Boolean, we want to have trues and falses. So I will define two sets, trues and, oh my God, I keep clicking on this. Trues and false, and I will make a little function. To Boolean, if pd.isNA, we return it as it is NA. S the string v dot strip dot load. Then if it is true, we return true. If it is in the true set, if it is in the false set, we return false. And otherwise, we return NA. So then what comes next, you may ask, and that is a very great question, my lovely people. Here, what we do afterwards is pretty much for is member, we say df.isMember apply, we apply the function to it as type Boolean. And when we run this, we can see we have 2492 trues, 2405 falses, and 103 NAs. Wouldn't it be absolutely horrible to go through all of these different types for that is member column, just for this column, if we wanted to keep that data? So it is significantly easier to work with a unified system. Again, um, any questions on this? Another important factor, another important part on this is percentages. We do also see a lot of percentages here and there. The rule is to strip the percentage sign. If the original had percentage sign, we divide it by 100. If the value is bigger than 1, we assume it was a whole number divided by 100. And if it is between 0 and 1, we will not do anything because it is already a fraction. You can change this the way you like. It is usually better to keep percentages as a float value between 0 and 1. It is usually more accurate to do it that way, unless it is for a specific use case. But my suggestion is to keep it like this. Okay? Let's see. I have a function here that does exactly that. We apply to discount, and after we run it, as you can see, we stripped the percentage sign off of it. If it had a value error, if it wasn't a float, we return, obviously. If it had a percentage, or percentage sign symbol, we return x divided by 100. If it was bigger than 1, we're assuming it's whole, we return it divided by 100. Otherwise, return x. And applied to that, we can see we have a better understanding of everything now. We have a maximum of 0.25, the mean is 0.09, and 75% is 0.2, yada, yada, yada. We have 5,000 counts. Uh, we don't have much left of this. It is pretty much, I guess two parts left to this. Uh, let's see. Oh, nope. Now, a lot of people completely forget about this. Uh, Outliers and impossible values. Dude, there's no way somebody's 200 years old. There's no way someone has an age of -5 or 999. That stuff happens. We don't want them. Get out of it. Get out of here. We don't want them. Or quantity equals -1. You're sending us a speaker or a microphone or a USB hub? What? 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 No, doesn't work that way. So we would have to remove them or set them to a mean. Domain rules. If we follow domain rules, explicit known bad ranges, always do this first. And then the second step is statistical. IQR or Z-core for everything, Z-score for anything, domain rules don't catch. Um, and I will explain what each of those are with the code examples. This is the domain. The age, for example, for the website that you are selling the product in example has to be between 13 and 120. As an example, if you are working with a data set of people who are car buyers, it has to be from 16 to 120 again. If you're working with a data set about teenagers, it is going to be from 13 to 19. If you're working with a data set about young adults, it's going to be 20 to 35, 20 to 40, whatever that range is. It all depends on your domain. What are you working with? What is your understanding of your data? Now, once you have those rows of impossible ages, you will set them to nan, disprove them completely. Example, we're printing them here. Uh, Order ID 2099 -5H. Come on, man. Who are we fooling? Who's -5? 200, 999, blah, 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 blah. So in the data set, we have 56 rows that had this problem. Okay, now, another would be quantity, negative values exist. So we check the schema, for example, if for quantity we have less than 0, we have to get rid of them. No matter what the product is, what the, excuse me, other information is. If it is negative quantity, we don't want it. That's not true. That can't be possible. Um, can someone tell me if we have removed these from our data set yet or no? Nah, you are correct, my friend. Ding, ding, ding. So I'm going to add another code block and then we impute them. We remove them. So then we fill the NAs with the age median and we describe age and that's pretty much it for that. Any questions so far, guys? So then let's move to we caught everything that domains catched or caught. Let's talk about stuff that the domain rules might not catch. Price USD. Generic IQR check for Price USD as a sanity demo. Not flagging anything as bad, just showing the technique here. So what we're doing is we're saying the IQR bounds for Price USD is a negative 487.50 all the way to 1012.50. What happens in the code here is I have to ask first before I even continue. Do you guys know what IQR is? Okay, that is a fair point. That's my bad. So, IQR per textbook definition, I'm reading off of Google because I don't know the textbook definition, honestly. Interquartile range is a measure of statistical disseparation that describes the spread of the middle 50% of a data set. You know how in Canvas, when professors grade, we have like stuff like this? IQR is this box right here. So, um, excuse me, why does this matter again? Surush? Why does this matter? Because sometimes, for example, with the price, we don't have a good negative or a good positive, and we're flagging price USD over here just to show that sometimes the prices might go off of the charts. So if it goes off of those domains, we don't want it to be necessarily a domain, but we want it to be we don't want it to be a set value, right? For example, age you can do median, who cares? But if a price is done wrong, you don't want it to um, just be any price of any product. Right? For example, let's say Michael orders a microphone that's like 30 bucks, and Jennifer orders a laptop that's 12.99. If, for example, Jacob places an order in that data set, the price is wrong, and they order like a I don't know, car. Do we want to get the median of a microphone and a uh laptop for that? It would be good for Jacob, but not for the company. Somebody's getting fired. Um, why that person be us, you know? So it is better to take the IQR instead. So if there's anything that the domains don't catch or we don't have a set domain, we use this to uh, handle. Any question, guys? Do we all understand IQR in this context? Okay, then. We move forward. Last but not least, we have validation. And for the instance here, I have emails, right? If the email here is bob at email or frank.miller.email at email, that's not the exact thing we wanted. So That's not a valid email address, so we can't really use it, and it's lost cause to do it. So instead, we need to have a set of rules that would apply to this. For example, um, something that really helps is regular expressions, regex. Some of you guys might have passed 329 already, and it is a important topic in there already that talks about it's like half of the class talks about regex and how the other things relate to regex. Uh, but when you don't have a regular expression, you can convert the field that you have into one or have checks for them. For example, you know how in applications, websites, when you try to put in an email and it's not the right format, it says, uh-oh, this is not the right format I'm looking for. What are you talking about? Or you type in the password with the characters that are not allowed, it'll be like, what are you doing? I don't understand this. That is because regex rules apply. They defined a set of rules. For example, here we have an email address to be A to Z, 0 to 9, 0 to 9, uh, underscore percentage plus, uh, I might be mistaking that actually. Hold on. Underscore regex is so difficult to read. Give me a sec, 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 give me a sec. Let me explain this properly. Let me explain this properly. My apologies. So our little, I don't know what it is called, anchor, I guess. It is the starting of the regular expression. Uh, the brackets are class or character classes. Any one character from this set will be allowed, the set that is inside of it. A to Z is lowercase a to Z. 0 to 9 is digits, obviously. Then we have dot underscore percentage plus as literal character. So I was not wrong. And we have a plus, an @ sign. Then A to Z, 0 to 9, dot, and then another class of characters, A to Z. And this has a limit of number of characters, usually, not always, but usually has a limit for the number of characters. Then we get all the valid emails, we print them over here, and we can see over here that we have 350 rows that have invalid emails. Now, on a good, well done system, this doesn't happen to begin with, but in case it does, here's how you figure it out. Any questions? Okay. We are ending. We're getting close to the ending. I'm gonna make another code block here. I'll put everything in so you guys can see it as I do it, and then I'll explain everything as we go. This, this, and this. Okay. Okay, so we rerun the same inspection commands from section one and compare. If the cleaning was successful, what do we do? D types should be sensible. It should make sense. Uh, no surprise NANs, only the ones that we want intentionally. Categorical columns should have a small expected set of values. You don't want thousands of email types or for example, you don't want thousands of domain names for the emails. If that is the case, then there's something wrong. We don't have that many email providers. Yes, the email name could be different, sure. But that, no. For example, we don't want thousands of values for is member. Distinct values I'm talking about. Thousands of different statuses. We don't want that. So then what we do is we make sure it's an expected set of values. And we also make sure there's no impossible numbers either. No 999 for age, no negative 200, no none of those. So that should be it. Any questions, guys? If there is no questions, that would conclude. That would conclude our workshop tonight. I hope you guys enjoyed. I hope you find it useful and it has information that you will use inside and outside of the Datathon. If you have any questions, I'm here. If not, you're free to leave. Yes, absolutely. Have a great one. Thank you and take care.
Hello.